Hi everyone, we are Group 0. I'm Qing Tang, and our group members are Kunpeng Li, Louis Lu, Liu Shenqi, He Tianyi Yu. And this is the content of our project. We are going to present the problem statement and objective, facts and figures, proposed solution, features, interface, benefits, and lastly scope. And this slide shows us our project problems and objectives. The problems are visitors can stand in line for one exhibition time for a long time. And also, inefficient arrangement of the museum layout reduce the chance for all display items to be seen by visitors. And the last problem is galleries and collectors do not have enough scientific facts to name price on collectible pieces. And the objective of our project is to help visitors pick a destination among different museums based on the heat map result. And our app will also provide real-time and historic heat map data to museums to optimize display efficiencies and crowd control. And the last objective is to accumulate historic data on how often visitors stop at the individual exhibition item to provide solutions to collector parties.
Hello everyone, I'm Kunpeng Li. I will introduce the facts and the figures. The museum attendance steadily raised over the last decade, and now we have over 10 million visitors in 2018, which is 25% growth compared with 2017's 10 million means we have 15,000 users go to museum daily who need to improve their experience. So we use the DMV as an example. The DMA has over 800,000 customers last year. For special events, the DMV will have 2,700 visitors in the 6 hours, sometimes even more. We gonna have the 5,000 visitors with 3 hours. So you can imagine how crowded inside of the museum, especially for the holiday exhibition. In order to saving people's time and enjoying their time in the museum, we have this app, Museum Heat Map nowadays.
Hello, my name is Louis. The key feature for this project is the heat map generation feature. We will use a list of nearby timestamped GPS coordinates provided by Google Maps and our algorithms to generate a heat map of local crowd density, which is then overlaid on top of a map of the museum for the user. The second planned feature is the ability to calculate an optimal route through the museum to a destination exhibit. This route will take into account crowd density trends from current and previous heat map data generation in order to avoid congestion and crowds when navigating through the museum. The third planned feature is a crowd density histogram for individual exhibits. This also uses the crowd density data from the previous heat map calculations, this time gathered over time, and it groups these densities around the locations for the exhibits in order to show the density trends for how many nearby visitors visit those exhibits. This allows users to plan ahead to see what times are best to see certain exhibits when the crowds are minimal, thus allowing for an optimal viewing experience.
Hi, this is Tianyi Yu. Here is our app interface. Here is our login page. We will cooperate with Facebook and Google, allowing our users to use their account to log in our application. Next, we want to help visitors to plan the trip more efficiently by providing real-time heat maps in the app so visitors can avoid heavy crowds. So here is our heat map function. The heat map will graphically present the visitor density data, which is more easier to understand because it's more visual. It uses color to represent density of visitors. Based on the historical crowd trend data, our system will automatically create the route suggestion, and this is our app design for route suggestion function.
All right, my name is Liu Shenqi, and I wanted to sum up the benefits of our application. First of all, with the real-time heat map, visitors can plan a much flexible trip to the museum. especially when the desired art piece is not the one that attracts the massive crowd. In this case, users can find a route away from the crowd to reach their targeted exhibition piece. Then museum can use the historical data to rearrange the exhibition layout, especially when they are redecorating or re-innovating the museum the interior. For example, they can leave a bigger buffer zone for those art pieces that has been historically popular, and this will work especially well for exhibitions for newer art pieces. And also, a museum can use the heat map data to generate recommended routes for new visitors in town, and that way, with the rearranging of the layout and the recommended route for new visitors, museum will be able to fully utilize the existing museum system. At last, we want to talk about the scope. So we want to form partnership with the museum in order to be able to collect data in their premises. Then we wanted to work with Google since our location data are from Google Map. And in this case, we wanted to point out that we don't really want any of the personal data from the visitors. The only thing we want is location data. So one thing is we can dodge a lot of legal issues. Also, you will be able to save a lot of money for us. And then we move to the expense. The initial estimated cost will be around for $140,000 for the whole system to be fully operational. And this estimation will not include the recursive expense with Google and maybe some museums, since we will want to collect the data for a relatively long time span. And in order to store those data, we will build our own database server, because the historical heat map data will be a very critical part of our operation if we want to make profit at the later stage of the application development. And that'll be all of our presentation, and thank you, and hope you like our application.